Hello again, everybody, and welcome to the top of page 130 in the workbook. And this is going to be a very short video that introduces something called the adjoint of a matrix. Okay, this definition is going to involve the conjugation of complex numbers. So let's take a minute just to review what that was all about. I'm going to just try to sneak a couple of examples up into the top margin here. Okay, so the complex conjugate of a complex number a plus bi is just the new number that you get by basically changing the sign on the imaginary part of the number. Okay, so the complex conjugate of a plus bi is just a minus bi. Okay, and let's do a specific example. What would the complex conjugate of 2 plus 3i be? Just 2 minus 3i. We'll change the sign on that imaginary component. How about the complex conjugate of just I? Okay, well there we would just get negative I. Maybe one more example. What if you took the complex conjugate of a real number? Okay, well there is no imaginary component, and so it would just stay the same. Okay, so we talked about that definition back in 6.0, but there's a quick review of it. Now we're ready maybe to tackle this definition that we have here. All right, so we'll start with an m by n matrix A. And we're going to define something called the conjugate transpose matrix, also known as the adjoint of A. You can use either of those terms. And it's going to be an n by m matrix that we're going to call A star, and here's its definition. Okay, you might remember this notation from way back at the beginning of the course. Okay, it's describing this new matrix A star in terms of its entry. So the ijth component of the adjoint matrix is going to be, and I just wrote over the top a part of the definition, so let me get rid of that. So the ijth entry of A star is going to be AJI bar. Okay, notice that two things are going on there. We're flipping the rows and the columns, that's the transpose part, and then we're taking the complex conjugate of it. Okay, that's the conjugate part. So if you play with that definition, what you can convince yourself is, if you start with a matrix, let's just take a specific example. Okay, I'm going to make it a 2 by 3. The conjugate transpose of this matrix you would get by doing two things. You would take its transpose, and at the same time you would take the complex conjugate of every entry. So we started with a 2 by 3, we're going to get a 3 by 2. And so if we kind of go down the first row here, we're going to make that our first column, but we're going to conjugate everything. So 1 is a real number, it's going to stay the same. I is a complex number, we're going to change it into its complex conjugate, and then 2 minus I. We're going to do the same thing there and change that to a 2 plus I. Okay, then we move on to the second row and kind of do the same thing. That's going to become our second column, and we're going to complex conjugate every entry. 3 minus I, 4 stays the same, and negative I turns to I. Okay, and so this matrix A star is what we mean when we say the adjoint or the conjugate transpose. Okay, this matrix will come back and play a role in the very last section of the course.